So we're going to assume that each juror's Bernoulli payoffs are, they get 0 if a guilty defendant is convicted or an innocent defendant is acquitted, and they get -Z if an innocent defendant is convicted, and -1 Z if a guilty defendant is acquitted. Okay? So now let's denote by R the probability a juror assigns to the defendant being guilty given all her information. So given that the juror has received all the information, the juror assigns a probability R to the defendant being guilty. So the expected payoff to juror J the expected payoff to each juror if the defendant is acquitted is -R multiplied by 1 - Z plus 1 - R multiplied by 0. And what this means, so the -R is the probability that defendant is guilty, and this is the probability that the juror assigns to defendant being guilty, and -1 - Z is the payoff if a guilty defendant is acquitted, and 1 - R is the probability that the defendant is innocent, and 0 is the payoff if an innocent defendant is acquitted. Okay? And that is equal to -R 1 - Z. And the expected payoff to each juror if the defendant is convicted is R times 0 minus 1 - R times Z, and R again is the probability that the defendant is guilty, and 0 is the payoff that when a guilty defendant is convicted, and 1 - R is the probability that the defendant is innocent, and -Z is the payoff when an innocent defendant is convicted. And that gives minus 1 minus R multiplied by Z. So, a juror prefers the defendant to be acquitted if her payoff from the defendant being acquitted is higher than her payoff from the defendant being convicted, right? So a juror prefers a defendant being acquitted if her payoff from the defendant being acquitted is higher than her payoff from the defendant being convicted. Right? Which means that minus R, 1 minus Z must be greater than minus 1 minus R times Z, or that R is greater than Z. And vice versa for the juror preferring defendant being convicted. So the juror prefers a defendant being convicted if her payoff from defendant being convicted is higher than her payoff from defendant being acquitted, and that it translates into Z being greater than R. And since R is the probability that juror assigns to the defendant being guilty, we can define Z as the probability of guilt required for the juror to want the defendant to be convicted. Okay? So if R is greater than Z, the juror prefers the defendant to get acquitted. So Z is the minimum probability of guilt required for the juror to want the defendant to be convicted. So anything great, so R being greater than Z means that the juror wants the defendant to be acquitted. And for any juror, so this means that for any juror, acquittal, and this is very important, is at least as good as conviction if and only if the probability of the defendant being guilty given the jurors information is less than or equal to Z.